Hello, Mas Dika.
Hello,
Thank you
how
so
are
much
you?
for spending your time with us. Yeah. Thank you so
Cool,
much
cool.
for spending your time with us, and thank you so much for willingly sharing all your knowledge with us. And today, um, as the theme of our international lecture today, we're going to have a handout material from Masdika, and our title of today lecture is about hand-on data analytic tutorial, creating a simple ETL process on earthquake dataset using Python programming language. And I welcome everyone to our lecture series. And without further ado, maybe I will hand the meeting to Mas Dika. And for everyone else, please pay attention to this lecture because we will have a quiz tomorrow. And make sure that your team will do your best in our next session of quiz. For Mas Dika, the screen is yours.
Okay, cool, cool. Thank you, Mbak Alvira. Okay, just going to share my screen right now. Just a moment here, and then I'm going to share my screen here. Okay, cool. Can some of you tell me if can you see my screen right now?
Yes, but unfortunately, there are some black box. It cover your screen.
Sorry, what? Pardon?
There are two blocks that cover your screen, so we cannot see the entire screen of. All right, now everything is settled.
Really, 2 blocks? Oh, okay. Just a moment. I'm just going to. How about if I just going to wait. Share that, and then just need to share my screen, which is my PowerPoint. Here. Boom. How about now? Sorry.
There are still two blocks.
2 blocks,
Yeah, and
okay,
now
that's quite
it's
funny.
3.
Last time we did a bit of a test with the 3 blocks.
Yeah, and now just 2.
Funny.
Yeah, I think it's okay.
Just a moment.
If it won't disturb your presentations, I think it's okay.
Just a moment. Okay, it's a basic screen. How about now? Is it still kind of blocked?
There are still 2 blocks there.
Oh my god, I don't know why it's.
Maybe
okay.
If you try to...
Okay. Wait. Maybe just going to. This is the okay. I'm going to do it last time. Optimize it for video clip. Screen share for video. Okay. Okay. How about now? Is it still kind of blocked? A screen from the side?
Yeah, but it's okay. Maybe you can try to full screen.
Yeah, good idea. Okay, just going to this one. Okay, how about now? Is the block?
Okay, yeah.
Okay, cool. We'll start my lecture right now. Yeah. Cool then, cool. Okay. Before I continue, I just want to say that thank you so much for the SCG community for inviting me as a lecturer for this for this event. Thank you so much. I'm really kind of very fortunate to be participate in this event, and also a big shout out to Mike SC. I think he's from the University of Cameroon for me to as a lecturer in this program. Thank you so much, everyone. Okay, cool. So as Alvira said before, today's lecture is going to be a bit of a data analytics tutorial where we're going to use the Python programming language to create and perform a simple ETL process on earthquake dataset, where the earthquake dataset is from the USGS database. Cool then. by the way, excuse for the quality of my PowerPoint slide. But in this lecture, the scope of the lectures, at least there are 3 points there. The first one is going to bit of explain how a data analyst work, where I'm going to explain a bit like their requirement as a data analyst, and also some of their tasks and assignment that usually we do in a more general way. And the second one is I'm going to give a bit of intro of the Python programming language. Where in here, probably I'm not going to deep dive about what is Python, I'm just going to give you a definition about the Python, what is Python, and also the capabilities and functionalities of Python. But just want to let you know that this first and the second point, this just going to be like a bit of a glimpse or a short one, because like the main point of this lecture is on the third one, which is going to create an ETL process using the Python programming language. Okay, going to our first part of the lecture is what is a data analyst. So actually, I just picked some of the code from the Coursera and also the other person, where the Coursera said that a data analyst collects, cleans, and interprets data sets in order to answer a question or solve a problem. That's the first one, and the second one is I just quoted from the Dr. Susan McKenzie. She's a senior associate dean from STEM from the University of Southern New Hampshire. Actually, I just did a bit of a Google, and she said that ultimately the work of the data analyst provides insights to the organization that can transform how the business moves forward and grows successfully. So essentially, if you want to kind of like conclude it, so a data analyst essentially is going to answer some of the business problems, or going to find some of the insights information, where they're going to use a given data set to answer those problems. But sometimes this data set, they need to other than gather, they need to kind of like extract or collect the data from one or two sources, something like that. So so this is more like the requirements, or maybe like skills that needs to be as a data analyst. But just take it as a grain of salt, because like as far as I understand until now, being a data analyst is quite I don't know. I'm not saying it is quite difficult, but it is quite complex if you want to grasp all of the skills, something like that. So if I want to pick some of the example, like this picture from the itcareercentral.com, essentially say that for hard skills for being a data analyst, we need to understand about the subject matter expertise, and which is more like understand about the business where we work, or where our problems at. And the second one is understanding about the data and the tools that we're going to use to process our data set, which is for the tools is quite also, again, it's quite diverse, where some of the tools, like for example like Excel or Python, to kind of like perform a manipulation or transforming data set. And maybe like some of you already knew about the visualization tool such as Tableau or Google Data Studio to create a dashboard, and some of them yeah, something like that. And also, other than tools, we also need to kind of like have a great understanding about the math, especially with the statistics and probability, because essentially that is kind of like some of the kind of a foundation for data analysts, and that's for the hard skills. And for the soft skills, still it is quite like a diverse one, where until now the several points that's kind of like important is the skill of communication and collaboration and also storytelling. Because like until now, I still kind of like a bit of a struggling on these 3 points there, the storytelling and also the communication. Yeah, because like for instance, like if we have if you have a great skills on data, on tools, and also understanding about the math subject, and then we apply those skills um, to those skills to maybe like creating a model on it, maybe like finding some insight of information. But if we kind of struggle to communicate our findings or maybe like our insights to other individual, I think that this it's kind of like a bit of a difficult to to get a bit of an idea about that. So yeah, essentially it's more like a collaboration between the hard skills and soft skills, something like that. Okay, so moving to the next part, which is the kind of like the uh, the test or assignment that we usually do as a data analyst, where at least there are six steps, where there are collection, cleaning, integration, analysis, visualization, and alerting. I forget what is alerting mean, but these 6 steps is more like a general way where there are several what I call several projects or work that are still need to do as a data analyst, such as like extracting the data from a data source, or maybe like creating a model for our business problem, something like that. But essentially, in a more general way, the work as a data analyst comprised with these six steps there. But okay, so but in this lecture, we're just going to perform at least 2. Actually, it is 3, which is that we already mentioned before, the ETL process, where the ETL stands for the extract, transform, and load. Where the extract should be like in here, where we're going to kind of like collect the data from the USGS dataset. Oops. Sorry, can you hear? Because say that my internet connection is unstable.
No, everything is fine.
Okay, okay then, cool. Sorry about that. So yeah, so the okay,
But now
so that's ETL. Yeah.
maybe to make sure that your internet connection is stable, maybe it's okay if you want to turn off your
I see. Okay, cool. Just need start video. Okay, cool. Yeah, I've already turned off my video, my webcam. Cool then. Just a moment. Just going to show again. There. Okay. Cool. Okay, so I think the last part is the ETL. Yeah. So yeah, so ETL stands for the extract, transform, and load. Where the extract is going to be like this part, which is a collection, where we're going to collect the data set from the USGS repository. And then from there, we're going to perform a transform process where it should be like in here, this part, which is cleaning, where we're going to kind of like going to do a bit of a manipulation, aggregation, and also transforming the data set so that so that it can be digested or it can be used to other people, because other times, okay, because most okay. So because most of the times, because most of the times when we kind of extract the data from the data source, the form of the result of the response is going to be a bit of a not structured well. So that's why we're going to a bit of a form a transform process. And then the load, I didn't see any load here, but load is more like the already structured data set is going to be load or stored let's say that in a local repository, maybe like in a database in our database system, something like that. Okay, so I think that is for the first part, and going to the second part, which is going to bit of a explanation about the what is Python programming language. So, sorry, I think I just forget to put a quote, but this I just picked this quote from the python.org website, where it say that Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. It is a computer programming language often used to build websites and software, automate tasks, and conduct data analysis. So if I want to kind of like say it in a more easy way, or in a more layman's term way, essentially the Python programming language is more like a bridge between us, a programmer, to our device, where the Python is more like a command, or like instruct to our device. So let's say that we want to create a, maybe for instance, like a alarm program to our on our device. So we're going to instruct our device using the Python as a language that can be digested to our device to create such a program, something like that. So it's more like a it's more like how we communicate how we communicate our device to perform such tests or activity, something like that. Hopefully that's quite understandable. Okay, going to the next part, which is this is just a bit of a general way about the application of the Python, and also which companies have used Python. So actually the Python is quite what do you call it, quite diverse with their capabilities. Where in here it say that Python can be used to develop a web and a website, and also creating a GUI, or maybe like an interface in our laptop, in our device, and then conduct a scientific and numeric analysis, and also creating a database access, creating games and 3D graphics, such. And yeah, it is quite a diverse for the Python capabilities. And some of the companies that have used Python, there are Netflix, and also Reddit, Instagram, Spotify, Dropbox. I forget what is this company name. Maybe somebody can mention in chat, because I forget to did a bit of research about this one. Yeah, so those are the companies that so far these are the companies that have used Python for their project, and also in their company. And I think by far, I think like the Reddit one is kind of like the most company that is quite Pythonist, where I think like more nearly 100% of their website use Python to develop their website, or creating their platform, something like that. Okay, I think that's the end of the presentation. And the next step is we're going to bit of a practice on creating an ETL process using the Python programming language. So I'm just going to exit my my sharing right now, and then just going to, so this this link will guide you to a Google Colab website. So I think so Google Colab is essentially like a notebook. Maybe some of you know the Jupyter notebook, but essentially it is where we can perform our program in Python, but not just Python. It can be used other type of language like R, bit of a, I think it can also creating an markup language using the HTML and also CSS, I think, if I'm not wrong. So essentially it is a bit of a easy way to to create a program without the need to install or download some of the package or the Python language, and also yeah, something like that. So you just need to open your Chrome But before that, I'm going Um, okay. Sorry. Can you let me know if there's any problem with opening the link, or is anyone able to open it? Hopefully, we can shout out in the chat room, or maybe I can just
Okay.
wait for about a minute, maybe like 2 minutes. Just make sure that everyone are opening the Google Colab.
Okay. So everyone, you can confirm whether or not you can access the link through the comment section.
I just tried the link and it works.
Beg your pardon?
Okay.
So,
Thank you for your confirmation.
oh, okay,
It
cool.
works, Mas.
Beautiful. Good to hear that. Okay, so Akashner said yes, nice one. Okay, just going to check it. Hopefully, it's not a bit of a. Sorry for that. Okay, cool. Okay. Okay, cool. I hope that everyone can able to open the link. So I will start again with the practice of the Python programming language. So in here, as hopefully it is quite the same with the interface in your device, in your own device, but essentially this is like a what do you call it? This is like a terminal where we can perform a coding or building an algorithm to create some of our project, something like that.
This
Yeah,
meeting is
so
being recorded.
okay, got it. Yeah, I think maybe I can did a bit of a tour about what is that. So essentially, like in here, this one, it's kind of like creating a cell where this one, or this one, sorry, there, here. and here one. So it's essentially this is like our workspace to create a such program. So for instance, like if I want to kind of print this bit of a like a cheeky one, but we usually do this one, hello world, and then I step into that, and it gives like the result per beside at the bottom of our cell. So yeah, so it's more like a creating a cell, and if we want to like create like this one, like create a title and also such text, you just need to create click this one, next one, and then you can just create a comment or maybe like some sentence. So it's more like a kind of like a presentation that can be used to anyone. Okay, so in our tutorial, I think that there are at least 5 steps, yeah, that on to create an ETL process. In this case, so this is more like a simple way to create an ETL process one. Okay, so so we're going into the first step, which is the import libraries. So maybe some of you ask what is the library. So library is more like an additional package in Python where it doesn't included in the original version of Python. So it's more like an additional kind of additional package that can be used in our Python language. So yeah, because since the Python is like an open source tool, meaning that people can many people or groups can contribute their work to improve the Python, something like that. So in our project here, we're going to use this for different libraries where the first one is you're going to what do you call it, to use the package of update time and also the request, JSON, and also the pandas libraries. I will explain it. I will explain what is the what's which. Sorry, I will explain on every this package later as the time goes by. Okay, so this is our first step, which is import all the required libraries, and then going to the second step, which is we're going to requesting the data from the USGS database through API. Okay, so maybe some of you again ask what is API, what is that? So API is more, if I want to explain a bit of a in easier way, API is more like how we communicate. Sorry, how we communicate communicate between different devices. So in this case, we're going to ask the USGS website, ask them to pull the data from their database. So in this case, we're going to ask them to pull the earthquake dataset and then pull it and store it in our own device, something like that. That's the more kind of a bit of an easier way to explain. So and the one thing that's quite cool with the USGS API is that we can kind of like perform queries. So queries is more like we're going to ask request the data in a more specific way. So maybe I can oh my god, oh it's bugging my, so just go here. So okay, so this is the kind of the documentation of the API in USGS, where in here we can ask we can ask the USGS on specific time of event of earthquake. So there's like end time, stop time, and also we can ask a specific location, and there are many types. That, we're going to use in the form of rectangle, that one, to kind of like in a rectangle to what I call it, to extract a specific location of the earthquake. Other than rectangle, we can also use in a form of circle. So you're going to input the point and also the radius on the of the earthquake event on such location, something like that. But in our case, we're just going to use the period of time of the earthquake, and also the location. And for the location, I'm going to use the, what do you call it, the radius. I'm going to use the in the circle form, where in here I use India as as an example case in here. So just going to open my Google Earth. So essentially, oh, I cannot. I'm just going to just a moment here. Cool. Hopefully you can see my Google Earth. So in here, I'm going to extract the data, the earthquake data set from USGS in this area inside of this red circle from here. Yeah, so although it's going to a bit of going to extract outside of the India, so like this one, what is this? So from Pakistan, several of the areas going to be in Pakistan and also Nepal and a bit of a area from China. But overall, it's going to extract data, all of the area of India, something like that. So I'm just going to move again to my Google Chrome. Just a moment. Okay, yeah. So here, in this tutorial, we're going to extract the period of time of the earthquake in 1 year. So we're going to extract from the year of 2019 to 2021. I'm sorry, it should be like in 2 years. So there's a 2 year span about for the earthquake data set. And then okay, I forgot to mention before. So in here, again, so I'm just going. So sorry. In here, this line of code, essentially, I instruct the Python to input this such value, which is in form of string, to input it in this word, which is, we call it variable. So variable holds specific types of data. Yeah, it's more like a mathematic, where we always use variable as a kind of like to store some figure, something like that. So yeah, in this case, you're just going to input the start time as in 2019 and also end time in 2021. And then the next step is we're going to state what is the figure of the latitude and longitude of our location, and also the radius. And in this radius is formed in kilometer. So in our radius, it's going to be like 1,435.5 kilometer, something like that. And this figure, the 21.0 and also 78, I just found it from Google, which is the center way. It is a center of India, something like that. Cool. And then we're going to the next piece of our code, which is we going to perform a request. So request, as I mentioned before, we already imported the request library, where the function of the request is that we're going to ask the USGS. Yeah, we're going to ask USGS for data set with this specific queries from the location and also the period of time, something like that. And then from there, we're going to store the result of the response to the response variable, this one. So yeah, so there's what do you call it? So that's the other part, and the last part is we're going to store the response, or the response of the result to JSON format. So JSON is more like a person's name. Yeah. So the JSON is stands for the, I think, keep forgetting the name of it. I think it's okay. JSON is a JavaScript object notation. So JSON is kind of like a universal language, I think, language or answer when we kind of like performing an API or requesting data. But this type of file, the JSON, it can be digested to any types of programming language, not just Python, but it can also be used it can also be used in other type of language such as R programming and also JavaScript, C++, C Sharp, and such. So yeah, it is kind of a universal answer for the programming language to be used to, something like that. And yeah, so first I'm going to give you a bit of idea. So, oops, sorry. Okay, I just messed up. Sorry, just a moment. Data inside start time here. Just a moment. Okay, cool. Sorry about that. Going to get a code here. Response slot should be like here. Just going to give it this and there. Okay, sorry for the a bit of a hitch like that, but yeah. So I'm just going to create some, then just going to show you how the result looks like. So the response, yeah. So I'm going to give you the response. Yeah. Cool. So this is like the result of when we kind of request the data, and kind of perform a requesting from the USGS website. So the 200, it is kind of like a code from the thing, if I'm not wrong, from the HTML, where it said that where if the result is in 200, say that it is it's success, which is the code is the requesting process is worked, something like that. And this response holds different different what do you call it, different method, no, different content, yeah, content. So for instance, like this one, in this variable response, we can kind of see a glimpse about what is the result of our request here, which is a bit of a kind of like a bit of a hectic one, this one. So this is our result. Essentially, all of this work is all the data about the earthquake that has been happened from 2021 to 2019 in the India and its surrounding. Although we are successful to request data from the USGS, as you can see in my screen, it is not that feasible to be digest to or to look at it like this bit of a like where it can be make you dizzy a bit of it, because there's lots of words and figure that's not that makes sense. And yeah, and that's why for the second step, second step, we get to perform. So sorry. So I'm just going to keep here. What is it? Response and then content. Okay. So yeah, so all of this have the different kind of values. Like for this one, it holds coordinates of such event of the earthquake. That one, and so there are lots of information and data in this variable of response. So in that way, we need to kind of like pick some of the points or pieces of information that we're going to use for further analysis. And that's why we're going to perform the next steps, which is extract all of the pieces of information that are needed. So we're just going to again, we're just going to choose some of the information that have been requested from the USGS, so that it can be used for the next further analysis. So in here, we're going to at least create sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So sorry, yeah, sorry. Okay, cool. I hope that also, if there is like a question, maybe you can just interrupt my presentation and then ask the question. It's okay. So you just ask directly from the, I don't know, maybe from chat or maybe like during the presentation. So yeah, from the data that has been requested, we're going to at least pick nine different information, which is stands for, which is there are ID and the magnitude. ID is going to be like the unique code for each every of the earthquake event. And then the next the next data is the magnitude, which is going to be like integer or figure of how big is the earthquake is, which is in I think it's in a Richter scale. Yeah, Richter scale. I don't know how to pronounce it. Yeah, so that's in a form in a measurement of Richter scale. And the third one is the location, which is going to be a detail about where is the earthquake event happened, which is going to be like in a sentence or yeah, in a sentence or words. And then the event occurred, which is going to be event occurred. Oh, sorry. This event occurred value is
The
going to
recording
be
has
like
stopped.
okay. The event occurred is going to be like the event occurred. The when the event of earthquake happened. So it's more like a date or a time, a date and time of the earthquake. And then tsunami is more like a what do you call it? It's more like a if it is the earthquake, if okay, Ikezue Cristobal, you can ask question, please. Okay. So Ikezue
I'm sorry
with any
for
question?
interrupting, Mas
Yeah.
Tika. There is someone, Ikezue Christabel. She is raising her hand. For
Yeah.
Ikezue, maybe you need to ask something. You can just ask it.
Yep. You can ask question, Ikezue.
This meeting is being recorded.
Or maybe if your audio is
Maybe we can continue first.
okay, cool. Also, if some of you have a bit of a if your audio is not working, maybe you can just chat in the chat room, then I can just read it. It's fine. So okay, I will continue my presentation, which is I think I just started from Isonomia. So Isonomia is more like say that if this earthquake will affect any tsunami event, something like that. So it's more like a yes or no value. So type is more like the type of the earthquake, and the longitude, latitude, you'll know, which is the location of the earthquake event, and the depth. That's more like a okay. Just a bit of a context that I still kind of like hesitate if this values should be a depth, because I will show you later. Since yeah, I'll show later why I kind of like curious, kind of hesitate if this name is depth or not. So yes, at least again we're going to extract the data from the response result to be at least 9 different informations, something like that. And then okay, so this code we're going to perform a kind of like a loop function. So in Python or in many programming language, there is a function named loop, where we're going to perform a repeatable process on such such data. So I think I forget to explain to you what is the list type. So just going to create a new cell, and then so in programming language there's a type of data which is named list. So maybe I can just state X, since is a list where it's going to contain about 1, 2, 3, 4, 5. So in here in this cell I just stated that X holds for about 1, 2, 3, 4, sorry, 5 different values, where it's stand for the 1, 2, 3 until 5 figure. And so and also it holds in the form of list. So if I want to kind of perform for a value in X, then I want to print it out, the all of the value in this X variable. Sorry, I'm just going to print value. Then it will show you which, yeah, so it will print out all of the value in this X variable. Or maybe like we can try another one, which is going to be test, and then I don't know, SEG, and also we can 3, 4, and then and then type 1. Yeah. So we're just going to create execute this cell again. Then again, just going to kind of like perform a repeatable process on this X, which is holds as the type list type of data. So yeah, that's the type of the list. So in here, okay, so just a moment. So I'm just going to give you this the data contained in the features variable. A feature sorry, feature, is it feature and s, a feature and s. So features, boom. Okay, so essentially this feature variable holds a list of all the response that we just requested from the USGS, where like for instance, this is the first value, which is there are contain like type, feature, and then sorry, contain several information data, which is base. This going to be the data for the location. It should be like the 5 kilometer, and then time updated. Yeah, so there are lots of information contained in our response. So it's just going to pick some of the data inside of the requested one. And and if you can see it, there is a data which is in time, which is labeled as a time, where this is actually a time where this is in the form of a Unix timestamp. So if I'm not wrong, the Unix time is more like a format of time that can be used as a information of date. Either it is date, or maybe like in day, or maybe in time, a time such as like in hour, minute, and second. So I forget a bit of research, but the Unix timestamp just start their counting on 1970, in the year of 1970, but I forget which month or in which date is it. But yeah, so actually since the year of 1970, it has counted again and again until this date, which is in here. It's already been 1600 and oh la 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 la. And just want to implement that in timestamp in the form of millisecond. Yeah, millisecond, not in second. So it's a bit of a detail in terms of the data. So yeah, so essentially, so in here, which one? This look function is going to perform all of each value in it. It's going to it's going to choose each of the value and then pick the information inside of the value. So in here, for instance, like this this first value, we're going to pick this information, this one, and then the second one, and also just tsunami, the code, and such forget which one of it, but yeah, at the end you're just going to pick all of this data, that one. So yeah, and sorry, just going to this one, and then after we after we pick all of the value, we're going to store all of the data, each of this variable in ID, magnitude, location until depth, and then from that we're going to create a data frame, or maybe in we usually say it in spreadsheet form, or maybe in an Excel form, like in table, like there's a table, like a column and also rows. So so in here we're going to declare the data that has been collected and then store it in the form of spreadsheet, such that. So going to call the PD, which is that is the package that we have called this one. So just imported the pandas library and then set it as a PD1, where pandas is stand for the panel data frame, if I'm not wrong, where the pandas is usually used to to perform a transform and also manipulation process in a given data set. But in here, we're just going to form all of the value that has been extracted, and then place it, and then merge, form it in the form of spreadsheet. So if I want to show it to you, so just go df. So the value should be like here, this one. So the data that we just requested from the USGS, we just pick some of the value in it, and then store it in, and then store it. So in here we can see that there is like an ID column, ID location, magnitude, event occur, type is tsunami, longitude, latitude, and depth. So until this point, it can be said that we are able to create to create an algorithm to ask the USGS data set, and then pick some of the information that we want to, and then store it in the form of spreadsheet, just this one. Yeah, that one. But if we see a bit of a glimpse of our data, I think there's still need some of the a bit of a transform process, because like here, this column event occur, it holds the unique timestamp, which is for the majority of people, it's not going to be understand, like it really doesn't mean anything at all. And also like this one is tsunami, just hold the figure of 0, 0, 0. So the column is tsunami essentially is going to be like a boolean, which is stand for a boolean, which is like a form of two types of answer, which is false or true, and false or true and false, although yes or no, and again, and the other one is the 0, 1. And then from there, and then from here, you're just going to state that 0 is going to be false, and 1 should be true. So if it is true, it means that the earthquake going to create a tsunami. I think that's the word. Sorry about my English. So yeah, so you just going to transform, bit of a transform for the event occur, and also the tsunami value. Okay, that's why going to the next step, which is we're going to transform our data set. So this bit of a manipulation process. So okay, so the first step, we're going to create a function in our code. So function is kind of like a group of code, where this group of code is going to be used on several times, so that we're not going to call it every time on our line. We're just going to just going to call the name of our function, and then perform the algorithm inside of the function. So like in here, I just created a function named time converter, where we're going to change the data of the Unix timestamp, this one, to be in a form of day, and then the time where the event occurred, and also the date of the event, or the date of the earthquake event, something like that. So in here, we're just going to the function is going to be a time converter, and then you're going to pick every rows of this unit timestamp, and then convert it to the more in more digestible way. And that's our first transform process. And going to the next step, next transform process is we just going to change the depth into minus value. Yeah, because if we take a little bit of it off for our depth column, it's also about 10, 10, 10, 27, and 0.68, which is, I believe, earthquake is going to occur inside of our Earth there. So you just need to add times, multiply it by minus one, so that every value should be in minus that one. And the third part of process or transform is we're going to change the Boolean value into true and false. Yeah, as I mentioned before, we're just going to change this figure, the 0, 1, to be true and false. To be true and false, so that it can say that which of the event occurred is this earthquake event occurred, creating a tsunami event, something like that, or which one is it is not, something like that. And the last one of our transform process is we're going to create a classification of our earthquake, where I forget to mention the source of this information, but essentially I just kind of like use the standard earthquake classification from the scale, from the Richter scale. Sorry, Richter scale, where it's going to be at least 1, 2, 3, 4, 5, 6, 7. Yeah, 7 types of earthquake, where it will refer the type of earthquake from the column of the magnitude of this value, something like that. So there are at least like a micro, minor, light, moderate, strong, major, and great, where the micro is going to be 0 to 1.99, and then minus to 2 until 3.99, such until the great one, which is going to be 8 until 10 scale Richter, something like that. And then, yeah, that's all of the transform process. And if we take a look bit, how is the result should be like this one. Yeah, here. So, this one. Okay, cool. Yeah, cool. So yeah, so essentially this is the end product of our our ETL process, or sorry, our transform process, where it's going. I think I just added one new row there, which is the earthquake classification, where it will classifies the type of the earthquake based on the magnitude value, and then the other data that we just transformed is the event occurred column, where from the Unix timestamp we just converted to a day, to a more digestible way information, which is we just find the day, the name of the day where the earthquake event occurred, and also the time, and also the date, which is this one, which is in form, which is inside of the bracket at the end of the sentence, something like that. And the last one is the historic column, where you just change the figure to be a Boolean value, which is stands for true and false, something like that. And yeah, so we just been in our last process, which is going to import the data frame into a CSV file, which is stand for the comma separated value. It's more like a still in the form of spreadsheet like an Excel, but this form is more like a what do you call it? It's more to be easy to access in terms of the size of the file. So in here I just call I just call our dataset variable, which is df, and convert. I'm sorry, import. I think it's export. It's not import. Yeah, sorry. So I just ask the Python to export our transform dataset to be a CSV file. So in here, if we want to take a look of the data in the form of CSV, so just going to make sure, just want to perform again the length of code, and then move and paint your mouse to a bit of a left one, click it, and then you can see that in most left of pane of your screen, it's you can find the CSV file that has been transformed, and then from there you can just download it here, download the data, and then and then it will store in your local device. So just one, which is the form of it is going to be looks like this one, like here. So I just open it in. Oh, sorry, you cannot see my screen there, which is in a form like this one. Yeah, this one. So so you can access the already transformed data in the form of spreadsheet, something like that. And from here you can kind of like play with data set to perform a further analysis, or maybe like perform a simple visualization of the data set. For instance, I've already used the QGIS. I think some of you know that what is QGIS, where it's kind of like an ArcGIS software, but it is in an open source one, which is a free one. So I'm just going to move the share screen into my QGIS terminal. Boom, here, where I've already import our transform data into my QGIS, and then I just kind of like differentiate every earthquake event occurred based on the type of the earthquake, which is based on the recorded data, which is from the 2021 until 2019. It only have about 3 types of earthquake, which is there's like minor and moderate. Which is the minor is going to be symbolized by a circle with the purple color, this one, and moderate, which is a bit of a bluish, and the light type of earthquake is going to be like in green one. So that's our kind of like our ETL process. And so just let's just before I just going to finish my lecture right now, just want to let you know that just want to let you know that, so like from in here in this what do you call it, this Google Colab file that we just created, it is kind of like so we can use this what do you call it, this Google Colab notebook to perform a extraction data from the USGS. So like for instance, if you want to accept the data in different year, maybe like from 2000, I don't know, 3 until 2004, and you can just perform all of the data, all of the lines of code. Okay, syntax error. Sorry. Okay, sorry, I just forget to comment it. I'm going to execute again. Bam, bim, bam, boom, and essentially it will accept the data with the given period of time, which is okay, still in 16 and 14. Oops, a moment. So just one moment. How about if I just run all that? Here, there, one. Bim, bam, boom. Okay, maybe there is a bit of a hitch because the year still show the year of 1914, but I have already set the year from 2003 and 2004. I'm sorry about that. Maybe I will check a bit further how the USGS API was like. But yeah, so overall, I think like there's a bit of a practice on Python to perform a ETL process, something like that. So yeah, but Sabina, I think I've already done for my lecture right now. Just going to share my screen here. Okay. Okay, I think but Bila just has lost her connection there. Okay. Sorry, if there is like a comedian here, that what is the next schedule for this lecture?
Thank you, sir, for your presentation.
Hmm?
Uh, Thank you, sir, for your presentation. Just wait for a while.
Okay. Yeah, I think a bit of struggle with the connection there. Okay, I still couldn't find the moderator in the chat room.
Hello, hello, Mas. Because
Okay,
sorry,
hello. Yep.
because I lost my connection earlier.
Okay.
I just come back join. Okay, so for
Okay, it's
everyone,
fine. I just want you to know that I just finished my presentation right now. So hello, test.
or is it just me? Because I'm having a trouble with internet connection here.
Okay, maybe I just can type word. So yeah.
Thank you so much, sir, for this beautiful presentation. I think the
Okay,
connection of
cool.
Dell is not good.
I see. Okay, it's fine.
Uh,
No worries. Thank you,
so
Abhishek.
it was a
So,
great presentation. and it was very informative. I think if
Okay.
she's back, sir, she's back.
I think, yeah, I think I'm back online. Okay,
Cool.
so Mas Dika, thank you so much for the presentation. Thank you for sharing with us. Before we close this session, maybe I will sum up some material that had been delivered by Mas Dika earlier. So basically, we're talking about data analyst and what we do in data analyst. Actually, basically, we collect, we clean, and we interpret the data so everyone can easily understand about the data itself. Being a data analyst is quite challenging, but as long as we have hard skills and soft skills, it doesn't matter because as long as we can interpret and communicate the data to the audience or to the user, then being data analyst, it can be easy. For the framework of the data analyst itself is layering, collection, cleaning, integration, analysis, and visualization. And one of the useful things and useful skills and useful language to perform data analysis is Python programming. So basically, Python programming is a programming language to build or create commands to execute a task to our device. And there are a lot of companies that using Python as their website builder. For example, Netflix, Spotify, Instagram, Reddit, and etc. So from everything that had been delivered by Mas Dika, we can conclude that data analysis and Python programming is quite useful for us, especially in geosciences field. Like as for the example, we can generate the data of the earthquake from the USGS or another platform, open source